By now you know a force creates acceleration and changes direction in solid objects. But here's some food for thought. Have you thought of how forces can actually cause changes within the solids? So for example, when you're pushing your bed, you don't just make the bed move. You also create a deformation from where you're pushing the bed. Understanding the deformation of solids is crucial to understanding how materials behave under different forces. So, today, we're going to explore the concepts of stress and strain and how they relate to the deformation of solids. Let's start with what deformation actually is. Well, simply put, deformation is a change in shape or size of a material, and it's caused by a force that's applied to it. Now, this force can either be tensile or compressive, meaning it'll either stretch or compress the material. So when you're pushing your bed across the floor, the bed will deform inwards or compress at the point where your hands are touching the bed. This would be an example of a compressive force. And when you pull on a rope, it stretches and tightens. And this is because of the tensile force that's acting on it when you pull it towards yourself. Now you can also think of these forces by picturing a stretched out rubber band or a compressed spring. And these are both examples of deformation caused by forces applied. Now, forces that compress an object and cause it to reduce in length are called compressive forces. So, for example, the compression of a spring in a car's suspension. And forces that cause objects to stretch or extend are called tensile forces. So, that's the force you're applying when you're pulling back a slingshot. Now, it's important to note that not every form of deformation is the same. So, let's take elastic deformation, which is when something is deformed by a force, but once the force is removed, it gets back to its original shape. Like a rubber ball being squeezed and then returning back to its original shape. But plastic deformation, on the other hand, is when something is deformed by a force, but does not take back its original shape even after the force is removed. Like a paperclip. A force will bend it, but when it's released, it will not go back to its original shape. Now the question is, how do we quantify the amount of deformation in a material? And this is where stress and strain come in. Now, stress is the amount of force applied to a material per unit area. It's pretty much the same as the pressure being applied to a material. It even has the same equation, that is force over area. And just like pressure, stress is also measured in newtons per meter square or pascals. Think back to when you were pushing your bed. The force of compression was the force you were applying, and the area that your hands covered when holding the bed was the area we are referring to in the equation. And if you can incorporate these numbers into the equation, you'll get stress. And it's this stress that causes the bed to deform, momentarily of course. Now if the stress was higher, that is you applied more force or reduced the area that it's applying to, the deformation would also be higher. And if the stress was lower, that is, if you applied less force or spread it across a larger area, the deformation would also be lower. Now, strain, on the other hand, is the amount of deformation on a material due to stress. You can think of it as the amount of stretch or compression that the material is experiencing. So for your bed, the strain on it would be the ratio of the length by which the bed compressed when compared to the bed's overall natural length. And we can take simpler examples too, like the stretching of a rubber band or the compression of a spring. In both cases, the tensile stress will be calculated as the length of the extension or compression. So if you have an elastic rope with an original length of 10 meters, which upon being pulled extends by another 1 meter, then the tensile strain is going to be 1 over 10. And since it's a ratio value, tensile strain has no units. Let's look at another example. Let's take a rubber band that's 5 centimeters long and has a diameter of 0.5 centimeters. We apply 5 newtons of force on the rubber band and it stretches by 1 centimeter. We can calculate the stress on the rubber band using the formula force divided by area. And the area here is the cross-sectional area of the rubber band. Now in this case, the tensile stress comes out to be 25.46 kilopascals. Now we can also find the tensile strain on the rubber band by using the appropriate formula and plugging in the values for extension and total length. That is 1 centimeters and 5 centimeters respectively. And this comes out to be 1 over 5 or 0.2. So why are stress and strain important? Well, they help us understand how materials behave under different forces. And when you understand how a material behaves under different forces, you can predict when a material might fail due to its deformation. For example, if we know the stress and strain values of a material, we can predict at what point it might break and under what amount of force. Now, rest assured, we will be taking a deeper dive into how exactly we use stress and strain relationships to do exactly that, but that's for the next unit. As for now, just keep in mind that stress and strain, they're both crucial to understanding the deformation of solids. And until then, dos vedanya.